Very good. I'm going to move over to the next visualization, which is related to the named caches. In my environment, I have about 40 named caches. I know that there are a lot of people that are using, let's say, near cache topologies, and obviously most commonly used is a distributed caching topology. So what I'm going to do here is show you an example of a near cache topology in this environment. I have several named caches. By the way, if you have a lot of named caches and where you have special naming conventions, you can filter them very easily. So you don't have to look at, in this case, 40 named caches that I have environment. So I have some named caches with the word sale in it. So I'm going to filter it. Well, guess what? I have about really 3 named caches: sales promotion, sales specials, and sales clearance. And what I'm going to do is I'm going to group them based on the tier that they belong in, which in this case has in near cache topology, you have the front tier and the back tier. Okay. So let's measure, for example, well, why did you use near cache in the first place? Well, let's look at the information about the whether or not it's effective from a data retrieval policy. So what I'm going to do very easily is select the data series that I want. I'm going to say chart the get column. Okay. So you would expect to see that there will be a high rate of gets for your front tier caches as opposed to the back tier caches, which is what you're seeing here in this chart. Okay. So the green line here is for the sales promotion front tier, and the blue line is the sales promotions back tier. Now, in an ineffective cache near cache hit miss ratio is, let's say, for example, if I look at the sales specials cache. Well, guess what? The sales special cache is very much alike. So you really, in this case, are thrashing more than what you're not getting the benefit of a near cache in this case. Okay? So this helps you, fine-tune these things and figure out what's the appropriate size of your near caches, which you can tell based on the measurements that we here. In addition to that, there's a number of other columns that you can also insert. Okay, hit counts, get counts. So for example, if we look at hit counts, I can do that very easy. Just insert this column. Okay, or if I want to insert throughput, gets per second, for example. All right, so let's look at some other violations that also took place here. I'm going to go ahead and reset my filter because I have some thresholds set on other named caches that I have in environment. So for example, I have a named cache called the large volume size map. So let's just go ahead and find that here. And I'm going to turn off my grouping, which basically you can group based on tier, cache type, persistence type, and service type. Okay, so no grouping. I'm just going to sort by the name. Or if you're looking for things like, for example, who has the most number of objects. Now, keep in mind, this is aggregated, okay? We're not looking at every single cache partition. We're looking at an aggregated set of metrics across the environment, okay? So it doesn't matter how many nodes you have. All this is rolled up, and we do all the work for you to do that, okay? So we'll look at a cache that has the most number of objects. Well, it's my inventory cache, okay? The ones with the least number of objects, no problem. It's cache R at this point in time, okay? Like, same thing for memory utilization. Okay, so I'm going to go ahead and look for some violations. So here's this one right here. This is the one I'm looking for. And I'm going to say plot the number of gets column. So you can see that for this particular name cache, I set a threshold where if it exceeds 1700, I want to know about it. If it exceeds 1700 gets in a 10-second interval, okay, I want to know about it. And that was a violation right there. Now, the violation here happens to be a major violation, but you can, of course, configure it any way you want here. In this screen, the flight data recorder also is available, where you can also scroll back in time. Okay. And by the way, remember we took down a couple of storage nodes? When did that happen? At bookmark number 24, which basically could have impacted the performance or the get throughput of a particular named cache, depending if it was or not it was rebalanced or not. Okay. And here you see that there was an event here that took place that may have caused some performance loss here. Great. I'm going to jump over. I'll show you the heat map last. I'm going to jump over to what's called the session charts. Okay. For users who have Extend TCP sessions, and before I showed you, I had about 24 Extend TCP sessions. I can monitor these sessions live. So, for example, this is the client address and the proxy host that it's connected to. It's measuring total bytes and total bytes sent and received within that session, in addition to other things like message counts, which are also information that we can track. Okay? and it will tell you how long, when the connection started, and the total bandwidth that was, total network utilization of that particular session. You can group these sessions by client address or by proxy host. Okay, so if I group it by proxy host, I have 2 proxies in my environment, and these are the number of sessions that I have. Okay, I can also filter. Again, you can filter on any types of attributes by proxy or by client host, which makes it easy to to limit the information that's here. Furthermore, I can also show you the historical sessions. So, for example, these were sessions that were previously connected once before, and we keep an interval of approximately 2 hours of sessions that were recently disconnected. Okay, which is what you see here. You can't plot this; it'll just show you the total bytes sent and received for that connection, when it started and when it disconnected. All right, moving forward to the node dashboard. Now, the node dashboard now gives you the ability now to drill down into each of these JVMs, right? So, for example, if in this case I have a host that has about almost 10 storage nodes run on it. Okay, so if I looked at other hosts that I have in my environment, let's take this Solaris host, where now it only has 3 JVMs. Before I killed 2, they had 5. All right. So in this case, I'm looking at a process called 292, which is a process ID. So if you don't name the process properly, you're only going to see process IDs, which is obviously not fun to look at. Okay. So when you click on this one, let's say node D. Well, now you know what you're talking about, or what you're seeing. Node D is a storage node, which is caching data for various named caches. Again, you have no control, right? Coherence does all the distribution, right? So it's storing about 22% of the data is inventory, and the rest, and 21% of the data happens to be a named cache called medium file size map. Okay, and it tells you how much units it's consuming on that JVM. Okay, keep in mind that in your cache configuration files, you may want to enable binary unit calculation. This allows us to arrive at a byte count, which is very useful. Okay. Furthermore, in the JVM, well, I can look at the JVM memory utilization. Well, now, these JVMs, by the way, are very small. As I mentioned, they're allocated 128 megs. Typically, you probably have 1 gig JVMs. And in your JVMs, you will see these seesaw patterns where memory availability drops down to a low level, and then there's a garbage collection event that happens, and it frees up memory. Well, let's look at the garbage collection, right? So I'm going to click on this Customize button on the right-hand corner here. And in here, I can do a couple of things. I could change the layout of this screen, okay? Furthermore, I can look at other KPIs that I can trend. So if I want to look at garbage collection, I can go ahead and drag this garbage collection down to this lower quadrant, and it's going to show me the garbage collection over the lifespan of this JVM for as long as I had this JVM running. And you can see that at this point in time, at approximately 12, 18, 30 seconds, there was a garbage collection event that took place 345 milliseconds. This is an aggregate view across 10 seconds, by the way, so it's still pretty good here. And of course, because the garbage collection occurred, you see memory available for that what's freed up for that JVM. Okay. From a network perspective, I can also look at the packet sent and received utilization here. Other metrics that would be helpful, thread counts, for example. So, by the way, this doesn't have to be a storage node. This could be a client node that is a pure Coherence client. That could be a WebLogic client or some other app server. Well, you can monitor thread counts here, right? I can also look at its CPU utilization, for example, of the JVM.